Greetings everyone, this is Non-Expert here, back again for another video. Today we're going to be going through the second implementation of solving problem number 60. And if you did not go through the previous video, I would sort of urge you to pause this video and check it out. You can find the link in the description below, or you should see it at the top right corner of the video. So if you've already visited it, that's awesome. You would already understand the context of the problem. But if you've not, I'll just give a quick summary on it. You've been basically given a multiset or an array of integers, and you need to return whether it can be partitioned into two subsets where the sum is the same. So we've already gone through a pretty easy approach where we sort of divided our problem into two subproblems, basically, where you were either considering the element and not considering the element and sort of understanding from there. And in the previous video, we were using a lead code link, and we'll be using the same problem as the lead code problem which was given. Again, you can find the link in the description below. And today what we are going to be doing is we're going to go through a more DFS implementation. Now, the reason why I've made a separate video on this DFS implementation is basically whenever you have a problem like this where you're conjuncting or sort of building out uh, combinations, or building partitioning or subsets or so on and so forth, you could sort of divide this problem as a DFS problem. Um, if you can, that's very, very helpful for you, because over here we know for a fact that the subset that we need to partition into is basically we need to partition into two subsets. But you might face a problem here that an interviewer might just say that, hey, we know for a fact that your implementation is working, but it's not dynamic enough. It's just working for two subsets. What if you have k number of subsets, and all subsets that you build out should have the same sum? Is it possible or not? Can you build out a function like that? And when you have something like that, you cannot just use the same recursive implementation which you build out. Also, there are multiple other reasons why you should probably think of using a DFS approach. Just because when you sort of build out the graph, or sort of you take each element, you sort of build out something like a directed acyclic graph, just to understand whether the set that you have can be construed as a sum which you want. And that's basically it. So I'll get into the implementation, and you'll see that's very, very easy to convert this entire problem as a DFS problem. And I've already gone through a similar problem which is called the combination sum problem. Again, if you've not gone through it, I would urge you to check that out as well. I've sort of explained how the DFS implementation works over there, and we're going to be using the same principle. But as you know, whenever we start with a base condition. So our base condition is going to be, hey, if nums have not been given to us, then we need to return false. Do note over here that the value that you're going to be returning in the grand partition function is basically a Boolean value. The other thing, that other base condition that you sort of want to consider, is the fact that the sum of all the elements, which are all the elements inside the nums array or the list, all the values can be divided by 2. If it cannot, if it's computed into an odd number, for a fact that you cannot divide it into 2, which basically means that you cannot partition the value or partition the set into two subsets. So just for doing that, we've gone through the same approach before. We're going to be using a div mod function, and a div mod function is pretty simple to understand. Um, it's just going to take your sums and what it needs to divide by, and basically return the quotient and the remainder. Now, quotient is basically the target value which you want to compute on, and remainder is basically the remainder value which it has computed. So if it's an odd sum which is sort of coming out, for a fact that that's it needs to return false, because there's no way you can sort of compute two subsets when the entire set is sort of computing or summing up to an odd number. So let's just check that. Let's just say, hey, if remainder is equal to 1, or whether it's true, then you return a false. So quick this thing, if rem is 0, this is not going to happen. So basically we've checked for that. And in the previous implementation as well, I've sorted the array. So you might have a sorted array. The interviewer might give you a sorted array, but in this particular example, you've not been given that. So we'll make sure that the array is sorted. And the reason why we're sorting it is basically that if you've gone beyond the target point, for a fact that hey, me going forward with the iteration does not really make sense, because there's nothing more to achieve. So that's the reasoning behind it. That's where you sort it out. And I've already gone through a memorization, or whatever you want to call it, uh, implementation, where we use the recursive function, and we sort of updated it accordingly to follow the paradigm of memoization or whatever. But over here we're going to start off with that as well. So basically what I'm going to do is I'm going to construct a dictionary or a hash map, whatever you want to call it, and call it as memo. The variable name is memo, and inside the key value, what I'm going to do is I'm going to contain the target sum. So basically the target value is what we're going to consider, and the value which is there is just basically going to be, hey, whether it's a boolean or whether it's, I mean, whether it's a true or whether it's a false, just going to be a boolean value. So if your target is equal to 0, you know for a fact that it needs to return true. So this should make it, just should sort of help you out, but I'll just write a comment over here. The key is basically going to be the target achieved, target that you've encountered till now, and the value is just going to be a boolean value, whether it had returned a false or a true value. So as you know, we're going to be using a utility function, and the utility function we're going to just call DFS, and the two parameters that's going to use is index and target. I mentioned this before, and what we're going to do is we're just going to call this function through our can partition. So this is an inner function, we'll just call it. So we're going to start with the first index and then move on to the quotient, and basically use the quotient value that we've got as a target and then move on from there. So each element that you're presently on, you can sort of subdivide that and sort of build out a graph to understand whether the target value that you've computed so far, that can sort of get a set which has that particular target value. I hope that sort of makes sense. I know that's like a lot of words, but if I sort of implement it, you'll get a better understanding on it. So as usual, what we're going to expect is that we always return the memo variable and the target, basically the key, as the key, and whatever value it's going to return. And basically what we're going to do is we're going to write, hey, if target is not in memo, then we perform some operation, and if not, and if it already exists, then you just return this. So let's just compute that. So the very beginning portion of this particular function, you can just assign memo target as false, and then whenever you get a true value, you can update it accordingly. So this is just so that you have some value inside target. So you can say, hey, memo target is equal to false, and if target is greater than 0, only then do we sort of move on with our implementation. The reason for this is basically if your target is gone in negative, basically you've hit a value where you've included too many elements at that particular moment of time. And what you want to do is you want to find a target which is basically equal to 0. So basically the quotient that you got, when you subtract it with all the elements, you want to make sure that the target gets to 0. And that's basically it. So you can say, hey, if target is greater than 0, you don't really need to worry about all the other things. And now what we're going to do is we're just going to write a for loop like we do inside a DFS call, and inside the for loop we're going to do our recursive calls. One thing to note over here is that we're going to be leveraging the index that has been provided to us, and the way we're going to be using this index is basically we're going to use it as a starting point in our for loop and then move on from there. So all I have to do is I just have to call for I in range from index to basically length of nums. So all this is going to do is it's going to consider the index and then call for loop and then move accordingly. And all we have to do now is basically we need to call our DFS call, the DFS utility function, and recursively call it while updating the value of the index. So let's just say it as I plus 1. That means that you've already included the ith value, and since we've included our ith value, you need to update the target value as well. So let's just do that. We'll just say nums I. So if DFS I plus 1 targets I nums I sort of returns a true, that is basically whenever you keep on recursively calling it, and when it sort of fits this guy which is 0, and if it returns true, then awesome, for a fact that you've hit a set which has or rather you've come up with combinations which can compute to your target sum. And if that happens, all you have to do is you just have to update your memo target, and you just call this as true, and all you need to do is you just need to break out in this particular scenario, because you don't need to keep on processing on the for loop. So that's basically it. There's not much here to it. It might take you a little bit of time to just understand it, but just to give you a brief on it, if you know for a fact that this is a DFS problem, you know for a fact that you're going to be calling a for loop, and the recursive call inside that for loop. Inside the recursive call itself, you're going to be passing in the parameter which is going to be the index, just so that you can keep on updating the index. And this is something which I've gone through in the combination sum problem as well. Um, but keeping that aside, over here, if you want to check it out again, all we're doing is you have a DFS function, an index parameter, and a target parameter, and a target parameter is going to get updated every single time. And what we're trying to hit is basically we're going to try to see whether target is equal to 0. If it is, then we return it true. And if it is that way, then you know for a fact that the combinations that you've computed so far have actually computed to this guy. And that's basically it. So multiple combinations being formulated, and then you're just checking them. The best part about this thing is that I've actually faced a similar problem in one of my interviews, and what the interviewer said at that particular moment of time was that, hey, you computed this thing out, and I had used the recursive implementation, which I had sort of explained before. Um, but what the interviewer had asked at that particular moment of time was that you've returned a Boolean value, which is either true or false. But if I want to return the subsets, can you do that? Obviously, it's very difficult to do that through the recursive implementation. But if you have a DFS implementation, you can actually visualize it, and then you can save those values as well. Cool. So let's just try running this code. Hopefully, this should run. And awesome, you can see that's running fine. Let's just go ahead and submit the solution. And awesome, you can see that it's faster than 79% of the Python online submissions. It's basically running at almost the same complexity as the one as the solution which we had talked about before. But all in all, this is very simple to understand. I hope you get it. I'll try explaining it. And you can sort of not consider the meme-wise solution if it's sort of giving you a little bit difficulty. But basically, you have a DFS function, an index parameter, and what you're doing is you're just calling a for loop from the index value which has been passed in to the last value of nums, and basically you're considering pushing that value inside your DFS utility function and calling it again. So then you sort of move forward with it, and then you just keep on updating the values accordingly. And cool, so that's basically it. I hope that you were able to understand this problem. If you did, that's awesome. But if you were not able to understand it, and if you have any doubts, do leave it in the comment section below. I would love to hear back from you and just handle any of your queries. Um, and if you did like this video, do give a like and do subscribe to the channel. We are discussion over here, and we would love to have you on board with us. And if you want to subscribe to this channel, you're awesome. We all know it. And have an awesome day. Thank you.